Hello everyone, we are back and we are doing a two-factor ANOVA. So this is a participation question that we had in class, our practice with a partner. So 30 participants were randomly assigned in both light and tempo conditions. There were 5 participants in each condition. One of the independent variables that was manipulated was the tempo of music participants heard. Slow, medium, or fast. One of the independent variables that was manipulated was the lighting of the room they were in, dim light versus bright light, and what was being measured was reaction time. So we're going to do our 6 steps of hypothesis testing for this two-factor ANOVA. Remember, we're not going to calculate two-factor ANOVAs from raw data. We're going to start at step 1. After step 1. So notice we've already calculated sums of squared between treatments, sums of squared within, and sums of squared total for you. We will still kind of do the other pieces of it. So we will still need to calculate our degrees of freedom. If we look at what our big N is, it says that there are 30 participants, so our big N is 30. If we look for K, well, we have a 2 by 3 factorial design, which means we have 6 conditions. We have dim, light, slow, dim, light, medium, dim, light, fast, bright light, slow, bright light, medium, bright light, fast. So K is going to be equal to 6. And the prompt says that there are 5 participants in each condition, so our little n is 5. So again, this is the information we already have from the prompt. We would need to go ahead and finish step 1 by calculating those degrees of freedom for sums of squared between treatments. K is equal to 6, so we would have degrees of freedom between treatments as 5. Our degrees of freedom within treatments, we have 30 participants, we have 6 conditions. That would give us degrees of freedom of 24. And our degrees of freedom total then is either adding those 2 values together, which gets you 29, or if you did big N minus 1, it would also equal 29. And again, the other sums of squared values had previously been given to us because for 2 factors, we're not going to calculate from raw data. Now, graphing is not required, but it can really be helpful. So when we look at this already, we can see that there's likely an interaction here. We see the crossing of those lines. We also see very different kinds of things are going on. And so when we look at dim lighting, we see that tempo is kind of goes down. As tempo gets faster, reaction time goes down. But we see when we're in a bright lighting condition that is not the case. We see in a bright light condition, we don't see big differences in reaction times except for that medium tempo. So again, we can see that there's likely things going on. Again, we can likely see that there's also likely main effects here when we kind of look at the differences between these conditions. Okay, so let's do step 1, the hypothesis. Remember, we're in a 2-factor ANOVA. We're going to do a statistical test for the main effect of each independent variable and the interaction. So for the main effect of light, we're going to have a F test, which means we need to have 2 hypotheses, right? A null hypothesis and a research hypothesis. We're going to do null hypothesis significance testing for the factor tempo, the main effect of tempo. So we're going to have a null hypothesis and a research hypothesis. And we're going to do null hypothesis significance testing, that F ratio for our interaction. So we need to have a null hypothesis and a research hypothesis here. So again, for the main effect of light, we'll see that mu1 is equal to mu2. For the null hypothesis, there is no effect of light on reaction time. Notice that again, that independent variable and that dependent variable are included. For for our research hypothesis, that those 2 are not equal. Because this has 2 levels, we're going to do this the same way we did for our t-tests. And so we're not going to, these are the formats that we'll use for that. When we look at tempo, that one has 3 levels. And so the skills that we used for our ANOVAs are what we're going to be used here. So our null hypothesis, there is no effective tempo on reaction time. Again, that would put all 3 populations as equal to each other. The research hypothesis, there's at least one of the tempo means that'll different than the other. in terms of reaction time, and the mathematical would be not the null there. For interaction, we won't have a mathematical way to write that for this course, so we'll just write there are no interaction effects between light and tempo on reaction time, or there is an interaction between light and tempo on reaction time. For step 2, we're going to calculate those degrees of freedom. Remember, which degrees of freedom we use for each of those F tests will depend on which degrees of freedom went into calculating that F ratio. So for our F ratio of light, we'll see that degrees of freedom light and degrees of freedom within went into that calculation, and so those will be the two we use. For the degrees of freedom for tempo, we'll use degrees of freedom tempo and degrees of freedom within, because that's what will go in. And for degrees of freedom interaction, we'll do the same thing. We'll do degrees of freedom interaction, degrees of freedom within, because that will go into that F ratio. So we calculate those values. Again, the first 3 we had already calculated. For our degrees of freedom light, we have 2 rows. We have either bright light or dim light. So 2 minus 1 gives us 1. For degrees of freedom column, we have 3 columns: tempo, slow, medium, and fast. So we have 3 minus 1 equals 2. And our interaction will just be that degrees of freedom between treatments of 5 minus those 2 new degrees of freedom that we calculated. Because remember, those are in an additive relationship to that degrees of freedom between treatment. So for step 3, we're going to look up the cutoff values, those critical regions, for each of those 3 distributions. We have for light, that will be 124. For tempo, that will be 224. And for the interaction, will also be 224. Again, if we don't give you a alpha level, you always assume that it's 0.05. So we're going to have that be 0.05 here. So for light, that would be 124 is equal to, F is equal to 4.26, F critical. For tempo and interaction, because they have the same degrees of freedom, that value will be 3.40. Again, when we look at these kind of information that we have, what we're going to need for step 2 is we're going to need to calculate the T's just looking at the effective tempo, and we're going to need to calculate the T values just looking at the effective light. So we're going to want to kind of combine those, and so we'll take for our slow condition, we'll take our total of 30 and we'll add our total of 15. That gives us a total of 45. For our medium condition, we'll do 15 plus 45. That gives us 60. For our fast condition, that will be 5 and 20. That gives us 25. We're going to do the same thing for light. We're going to add 30 plus 15 plus 5, which gives us a total of 50 for that column. And the T value for bright light will be 15 plus 45 plus 20, which will give us a value of 80. Does not matter how you add those up. If you add all of those individual conditions, if you add the 2 for rows or the 3 for columns, either way you get a G of equals 130. Again, we had already calculated step 1 previously, the sums of square between, within, and total. Those were given to us. And so these new values are what we're going to use for our step 2 in our step 4, part 2 of step 4. Also think about there are 5 people in each of these conditions. So this value 50 has 15 different values in it, because there's 5 from slow, 5 from medium, 5 from fast in that dim light condition to equal that 50. So our N for this T value will be 15. Same thing for bright light. That N for that T value will be 15. So how many scores went into that new T is going to be what that N is asking you. So for those formulas, again, we said that there was 15 people in each one, 15 people in the bright light condition and 15 people in the dim light condition. Again, we're going to want the 2 values on one side of the equation to equal the N value on the other side of the equation. So we'll see 50 squared divided by 15, 80 squared divided by 15. We'll add those 2 together. 130 squared divided by 30. So when we do that math out, we will get a sums of squared of light of 29.99. Now, if you rounded differently at a step, you might get 30 exactly, but if we're rounding to 2 decimal places at each step, this is what we'll get. When you do for tempo, we have 3 different conditions. And so again, 30 people, we had 10 people in each of the tempo conditions. So 45 divided by 10, 45 squared divided by 10, 60 squared divided by 10, 25 divided by 10. And again, notice that equals, those 3 10s together equal 30. Again, we want to kind of balance those values out. And so again, when we do those calculations, we get 61.67. To look at our interaction, we will take our sums of square between total that we had already been given of 196.67. We'll subtract that 29.99 and that 61.67, and that gives us 105.1. For the interest of time, I have put step 4C, 5, and 6 all on one slide for each of the 3 F tests. So calculating our mean squared of light, we would take our sums of squared of light, which was 29.99, divided by 1. That gives us a mean squared of light of 29.99. We'll divide that by our mean squared within. Again, that's 130 divided by 24. That gives us 5.42. So 29.99 divided by 5.42 equals 5.53. This is more extreme than our cutoff of 4.26, so we will reject the null. When we do this again for tempo, we're going to now take those tempo sums of squares and those tempo degrees of freedom. So 61.67 divided by 2 gives us a mean squared for tempo of 30.84. Notice that mean squared within value is the same. So that hasn't changed. So 30.84 divided by 5.42 gives us 5.69. Again, that is more extreme than our cutoff value, so we will reject the null. The same thing for our interaction. 105 divided by our degrees of freedom interaction is 2. That gives us 52.51 divided by that same mean squared within that we calculated, 5.42, gives us an F value of 9.68. This is also more extreme than our cutoff value for light. And so again, we will reject the null. So here's that completed F table that has all of those values in it. We have noted that each one of those is significant each one of those F ratios is significant at 0.05. That's what those asterisks indicate. If you are doing a null hypothesis testing at 0.01 and you're significant, you would use 2 asterisks to indicate that level of significance. Again, statistical significance is not the same thing as practical significance, so we want to do those effect sizes. So here is our effect size for light, that eta squared for light. So we have 29.99 divided by 29.99 plus 130. We do the math on that and we get an eta squared of 0.19. We'll do the same thing for tempo, 61.67 divided by 61.67 plus 130 gives us 61.67 divided by 191.67. That gives us an eta squared of 0.32. We'll do the same thing for our interaction, 105.01 divided by 105.01 plus 130. We'll do the math on that and we get an eta squared of 0.45. When you're asked to describe any significant main effects and interactions, here all of them were significant, and so we would describe all 3 of those. So for the main effect of light, there was a main effect of light such that people had slower reaction times in bright light. So if you look at our row mean for light, you can see that reaction time is slower. It took them longer in bright light than it did in dim light. When we look at the main effective tempo, there was a main effective tempo such that people had the lowest reaction times in fast tempos. Again, if we look at that, we see that that's the lowest value, the 2.5 is our lowest reaction time. And so that's where we're describing that. You could also describe that as we had the fastest reaction time. You could say the slowest reaction time was the medium condition. You could list all three. Again, just kind of describing what that main effect looks like. And that interaction, again, each one will be different, but for this one, there was an interaction of light and tempo such that when taking a test in dim light, people performed fastest with the fast tempo. So again, in the dim light, the mean of 1, that's our fastest reaction time. But when they took tests in bright light, they performed fastest with slow tempos. Again, indicating that there's something different going on here, that caveat, that but. Again, you could describe this differently. You could say they were the slowest in the dim light condition in slow tempos, and then they were the slowest in the bright light conditions in medium tempos. There's different ways to do it, but this is one example of something that would be correct. On all three of those, notice that we have our F statements. We need to make sure we have our F, our degrees of freedom, is equal to our calculated F value. We want to say whether we were rejected or failed to reject. Here we rejected at 0.05, and so P is less than 0.05 for all three of those. And we've indicated those eta squares, those effect sizes. Again, you are not required to put your mean squared within, which is your mean squared error in here. But if you do, it's super helpful because you can build back ANOVA tables using a lot of this information. And so it is always a good habit to do that, even though it's not required. So this ends our quick tutorial on, wait, what was I doing on two-factor ANOVAs. Thanks, everyone.